Solving linear equations. So we have one nice rule we need to follow, and that's the golden rule. Anything you do to one side of the equation, you got to do to the other. And our goal is usually to solve for x, but sometimes they're creative and they'll throw in some other numbers. So let's go ahead and solve a linear equation. So we got this thing right here. Let's get rid of that plus sign for the second. Oh, let's go back. Come on. Okay. Now, not cooperating. There we go. All right. So we got 6 minus x equals 2x plus 9. So kind of the goal here is to get all the x's on one side and the numbers on the other. So we're going to go for the path of least resistance if we can. Maybe I want all the x's on the right-hand side. So I got a minus x there, so maybe what I would want to do there is I would want to add x to both sides. Remember, if I do it to one side, I got to do it to the other because I got to follow the golden rule. So I'm going to add x to both sides, okay? And that's going to move, it's going to get the x's on the left-hand side to cancel out, okay? And then if I'm doing that, then I want to move the 9 over onto the left-hand side. Since it's a positive 9, we would like to do the opposite of adding 9, which is subtracting 9. So we're going to do 2 steps in one. We're following the golden rule. Anything we do to one side, we got to do to the other. Okay, so 6 minus 9 is negative 3, and 2x plus x is 3x. Okay. The 3 and the x are attached together by multiplication, so the inverse operation of multiplication is division. Okay, and what we're going to go ahead and do is we're going to divide both sides by 3. If I divide the right by 3, I got to divide the left by 3. Okay, and we get x is equal to negative 1. Now, as we're working on our homework or our test or something like that, we'd probably move on to the next problem. But if we have a little bit of extra time, especially on a test, we'd want to make sure, does this in fact work? So what we would like to do is we would like to check to make sure this works. So we're going to go ahead and check. And what we're going to do is we're going to plug it into both sides of the equation. If we get the same number, then happy times, it works out. So we're going to do 6 minus x. So that's going to be 6 minus negative 1, which is minus and minus is a positive. So subtract something that's negative, that's something that's good. So we got 6 plus 1, which is 7. Now if we plug it into the other side, we have 2 times negative 1 plus 9. So 2 times negative 1 plus 9, negative 2 plus 9, which is 7. All right? So we get the same answer on both sides of the equation, so we can give ourselves a check mark and a smiley face because we've done that correctly. Maybe we can try to fix his eye there. His eye looks a little messed up. I don't know if I'm going to be able to fix it, but I'm going to try. Okay, I think I'm just going to mess it up. All right, let's move on to the next example. We'll pretend it's a good happy face. All right, so then they start throwing in stuff with fractions, and we got to get rid of those fractions. We shouldn't freak out too much. All right, so kind of the first thing we want to do with the fractions in the equations is kind of find what's going to be like a valid domain or what are acceptable values of the x. So I can't divide by 0. So any denominator is the bottom. Anything in the bottom that has an x involved or y involved, you want to make sure you don't get 0 downstairs. So you see how we got a 3 over x? We want to make sure that x does not equal 0. So we're going to say, okay, well, we're going to note that x cannot be 0. Okay, and so we're going to go through and we'll solve our equation. If we get an answer of 0, then that doesn't work. If we get like 2 answers, one's 0 and one's 5, 5's good. And 0 would be what's called extraneous, which means it's an answer that doesn't work. Okay. Now, we're going to get rid of the fractions, so it's going to make it look like a much more pleasant problem to solve. We're going to find the least common multiple, and that was one of the other videos on the YouTube that maybe you want to watch if you're not real familiar with finding the least common multiple. So I want to find the LCM of x, 3, and 6. Okay, LCM of 3 and 6, the smallest multiple or the least common denominator of 3 is 6, and then we also have an x. Okay. All right, and we're going to multiply everybody in the equation by 6x. And what I'm doing here is I'm making it 6x over 1 just to make it a little bit easier with doing the multiplication of the fractions. We can do a little bit of simplification before we do multiplications. When we multiply fractions, we go straight across, but maybe I see some like factors that I can go ahead and divide out. Okay. If it goes too fast, you can always pause the video as you're following along and hit replay, rewind a little bit if you miss something. So keep that in mind. Okay, on the first pair, we see that they have a common factor of x, so we can divide the x out, and we're going to have 6 times 3, which is 18, over 1 times 1, which is 1. 18 over 1 is 18. Minus. Common factor of the 6 and the 3 is the 3, so we can divide out a 3. And 3 goes into 6 twice, so we have 2. We got an x, and then that's all that's left over. And then finally, the last thing we want to do is divide the 6's, and we're left with an x. So now this is much more of a regular, I guess, quote-unquote, regular problem. We want to solve for the x there. We already have just x by itself on the right-hand side. We want to solve for all the x's. I don't want to say x is equal to 18 minus 2x because that's not a number. I want to know what number satisfies this. So we're going to follow the golden rule. We're going to add 2x to both sides to get the x's all on the right-hand side. Okay. And 18 is equal to 3x. The 3 and the x are attached by multiplication. So we're going to do the opposite, which would be to divide. So we're going to divide both sides by 3. And we get 6 is equal to x. Okay? And I'm taking my test or something, and I want to make sure this is a good answer. So we're going to check. And we're going to check it on the left-hand side, so we're going to plug 6 in. So we got 3 over 6 minus 1 over 3. And what I did here is I want a common denominator, so common denominator here is, as mentioned before, was 6. So we're going to make this 1/3 into a 2/6, and when I subtract 3/6 and 2/6, I get 1/6, which is what the original equation was equal to. So that earns us a nice check mark and a kind of a weird-looking happy face. Okay. Alright, let's do some more fractions. Alright, so again we have a little bit more complicated equation to solve. We got some more junk going on in the denominator. So I have an x squared minus 9, an x plus 3, and another x squared minus 9. They're all in the denominator. And they have x's involved. So you got to be careful about what x's we get in our answers at the very end. Make sure that we don't get a bad answer. So what we're going to do is we're going to make sure we don't get 0 in the denominator. So I'm going to set a denominator, x squared minus 9. We're going to note that that is a difference of squares. And so x minus 3 and x plus 3 is what that factors into. So that's part of the special factoring. This is a difference of squares. So we're going to note that x cannot equal plus and minus 3. If I plug plus and minus 3 in, plus and minus 3, when I square it, the positive 3 is going to become 9, and the negative 3 is a negative 3 times a negative 3, which is also a 9. So we'd have like, here we'd have like a 9 minus 9, which is 0. So we can't have that. In x plus 3, we can't have negative 3, and the x squared minus 9, the 3 and the negative 3 both are going to give us a hard time. So those are the bad values of x. So we're going to go through the process of solving this, and if we get an answer of 3 or -3, we're going to throw that out and say it's extraneous or it doesn't work. So let's go ahead and continue here. So the LCM here is x plus 3 and x minus 3. So how I know that is the x squared minus 9 and our orange thought cloud here, it factored into x minus 3 and x plus 3. And then the other factor we had was x plus 3. Well, it's already counted in the x minus 3 and the x plus 3. So we only need x minus 3 and x plus 3. So instead of multiplying everything by, like a 6x over 1, we're going to multiply by a little bit more complicated, least common multiple, and that's going to be x minus 3 and x plus 3. And that's what's going to happen right here. So we're going to multiply everybody by x minus 3 and x plus 3. And instead of doing that, because I don't have a whole lot of room here, remember x minus 3 and x plus 3 is the same thing as x squared minus 9. Kind of like multiplying something by 2 times 3 times x. Instead of saying it's multiplied by 2 times 3 times x, it's multiplied by 6x, because the 2 and the 3 make the 6. So I'm doing that because I'm a little bit limited on my real estate here. So I know I just said multiply everything by x minus 3, x plus 3. Well, it's the same thing as x squared minus 9. And what's going to happen is we're going to go ahead and we're going to distribute this to everything. That's what's going to happen right here. The x squared minus 9 is going to multiply every one of these. So anything I do to one side of the equation, I got to do it to the other. We got to keep things happy and balanced. So that's what's going to happen here. And at any point in time, remember, you can always pause the video and take a look at it or rewind it if something doesn't make sense. Okay. So here is the x squared minus 9. It's just now it has been distributed to the 3 pieces. Okay. And we're going to do a little bit of dividing out. So I got a factor of x squared minus 9 and a factor of x squared minus 9. Those cancel out. And what we're going to be left with is just an x. And I think I write that after we've done all the cancellation. So you'll have to remember that this first term is going to be an x. And then with the second piece right here, this piece right here, the x plus 3 is going to go into x squared minus 9, x minus 3 times. If you want, you can, so here's one of the advantages of maybe writing it in factored form, is it would be x plus 3 and x minus 3. So then you would see that the factors of x plus 3 and x plus 3 cancel out, and you're left with just an x minus 3. So that's what's happening here, and I'm going to go ahead and remove this stuff. And continue playing it. So here's what happens. I get an x minus 3. Oops, I think I didn't want to delete this one. So let's put that in this little cross out right here. Okay. And then finally on the last one, the x squared minus 9 and the x squared minus 9 cancel out, and we're just left with 3. So remember on that first one I said that all that's left is an x. So there's that x. And then the second one we should have a 4. And then also the x minus 3 should also be there. 4 and x minus 3. And then on the right here on the other side of the equation, we just have the 3 left over. Okay. Now we've gotten rid of the fraction. It is now a much friendlier problem. We're going to go ahead and distribute that 4 through. So we get x and plus 4x minus 12 equals 3. Okay. And we always like everybody, all the x's on one side and the number on the other. So we're going to add 12 to the left and to the right. So we're going to follow the golden rule, and we're going to add 12 to both sides. And we're going to get 5x is equal to 15. And we'll divide both sides by 5, and we'll get x is equal to 3. Okay? Now, this is important to check back with our note here, and we noted that x could not be plus and minus 3. So I got an answer of 3, but we said at the beginning it couldn't be 3 or negative 3. This is the problem. This means this is not a good answer. So we say, oh, no solution. And we give ourselves a sad face because it doesn't work. But if you want, you can give yourself a happy face because you did solve the problem. So, sad face because we didn't get an answer, but happy face because we did the problem correctly. So there was no solution. Now, had there been two answers, one worked and one didn't. So let's say I got an answer 5 and we went through and we checked it. Then that would be an answer. But we only got one answer and it didn't work, so we don't have a solution. All right, and let's do one more of this fraction business. One more. Okay, so we'll go ahead and write down this problem. Okay, so oftentimes what will happen is in the excitement of the problem, you'll just jump right in, you'll go through and you'll solve it, and you won't find what are the bad values. Bad values mean what happens when I divide by 0. So try to make a habit of if you got some sort of equation that you're solving for, is find out where you're going to get 0 in the denominator. And then all you got to do is set the denominator equal to 0 or not equal to 0, and that'll figure out what that bad value is. When we start looking for asymptotes and holes and that kind of jazz, you'll be doing that again. So this problem we got 8w plus 5 over 10w minus 10 and 4 equals 4w minus 3 over 5w plus 7. So kind of the first thing I'm going to do is I'm just going to make a note to myself, just off to the side, that what are the bad values of w. So I'm going to make a note that 10w minus 7 can't equal 0, and we'll kind of solve it like we normally do. So we're going to add 7 to both sides, and then we will divide both sides by 10. All right, and that's one of our answers. Not our answers. I mean, this is one of our notes that if we go through and we get an answer of 7/10, it's not an answer. It doesn't work. And we're going to go ahead and say, well, 5w plus 7 can't equal 0. So we're going to go ahead and subtract 7 from both sides, and then we'll divide both sides by 5. And w cannot equal negative 7/5 either. Okay? So we've kind of established that. And now what we want to do is we want to do a little bit of fraction busting. So what I might want to do is try to factor the 10w minus 7 and the 5w plus 7. However, they're already irreducible. We could maybe do some factor out a fraction or something like that, but that's not going to be very helpful. So they're prime, and so if I got 2 primes, I just take the product of them. So the LCM here is just going to be 10w minus 7 and 5w plus 7. Okay, so that's what's happening here. Okay, so we'll have all that jazz written in there. All right. So this 10 in red, this 10w minus 7 over 5w times 5w plus 7. That's the least common multiple. This is limited real estate, so I couldn't make that specifically say that on the page here, but that's what it is. And again, like the last one, we're going to go ahead and we're going to distribute to both sides. Anything I do to one side, I got to do to the other. Okay. And the other thing I did is I made it over 1. The reason I make it over 1 is just so I kind of remember, am I multiplying the top or the bottom? Just to kind of help myself out with the fractions. Okay. All right, so let me mention what happened here. Again, because of the lack of real estate, when I do the first, the left side, what's going to happen is the 10w will divide out with the 10w, And what I will have left is 5w plus 7 times 8w plus 5. And that's what we have right there. Okay. Now if we go back and I do the other side, I'm going to do this stuff in red times the 4w minus 3 over the 5w plus 7. So the 5w plus 7 is going to take care of the 5w plus 7. And what we have left is 10w minus 7 times 4w plus minus 3. There's the 10w minus 7 and the 4w minus 3. Right? Now, we got to do some foiling. So that's what's going to happen here. We're going to do first, outer, inner, last, first, outer, inner, last. So that's what's happening here. We're going to foil both sides out. And then we're going to start bringing everything together. So let's get rid of all this extra arrow junk. All right. So multiplying all of that stuff out. Okay, so we got all kinds of goodness going on here. All right. So what looks like happened is I lost part of my 4 here. So let's make sure I put this back in. I think it got erased on accident. So that's a 40. Okay. This is a quadratic, and how we solve quadratics is we set one side equal to 0, and then hope it factors. If it doesn't factor, then we might have to complete the square quadratic formula. Something else. Okay. But this is not really a quadratic because when I subtract 40w squared from both sides, it's going to drop out. And what I'm left with is a linear. Okay. So the 40w squared, the w squareds are gone, so it's no longer a quadratic, it's just a linear. So how we solve linears is we get all the w's or x's or whatever on one side and all the numbers on the other. Since I want to deal with more positives, I'm going to add 58w to both sides, and I'm going to subtract 35 from both sides. That will get all the w's on the left and the numbers on the right. So I have this 139w equals negative 14, and we will divide both sides by 139. We'll get w is equal to negative 14 over 139. So that's quite an ugly answer. And if you'd like, you can go ahead and you can plug it back in. It's not terribly difficult to check. It may be just a little tedious.